from yesterday. Okay. Yesterday, we set the stage, right? We set the stage. In fact, we did a lot of work to set the stage, right? We did A, right? We did A, we did R, right? We did A and R. So after A and R, now it's time to bring out the definition. Okay, I want you guys to be clear about the stage. Okay, because everything you need to know is starting from here. Okay, that unit circle is not the center. It's not the centerpiece. Hold on. Those special angle values, they are not the centerpiece of these of trigonometry. ARD is the centerpiece of this of trigonometry. Okay. So I would just demonstrate to you throughout these lectures how you can utilize this and analyze it all by yourself. You can do it. You can totally do it. Okay. You just have to make sure you understand my lecture, which requires you maybe listen to it over and over again. Okay. Now, we have A, we have R. So what is A? Let me quiz you. What is A? What is A about? A is about the input for all these 6 functions, trig functions. Everyone is a new rule. New rule, new rule, new rule, new rule, new rule. What is A? Look at your notes. Okay, this is not a test. This is not a closed book, closed notes test. Look at the what we covered. Is how we measure angles, right? How we measure the input. Angles are measured from the standard position, from right here. Okay, so in short, we say A is an angle in standard position, meaning that how the angle is measured, either counterclockwise or clockwise. Okay, counterclockwise is a positive angle. Clockwise is a negative angle. So it determines where how you get the terminal, how we get the terminal. R. What is R? R is a reference angle, right? R is reference angle. What the meaning of reference angle, right? So we need to have both of these. And this is a part of the stage. This is a part of the stage. Okay, this is a part of the stage. A and R. After A and R, and we have more things on the stage. Why? Because we need to have some specifics. We need to have some specifics. And then we say A is an angle in standard position, which means it's measured as the way described in A. And a point, the point, okay, so there's a description about this point. And what is that description about this point? Right? Once we have measured the angle, right? Once we have measured the angle, for example, okay, I'm gonna bring back another picture we have done, right? You can see in the entire process, I didn't use special angles. I could, right? But I don't want you to have the false impression that trigonometry is all about those special angles. In fact, the quiz you're going to encounter this week, okay? Quiz number 10, there's no special angle, okay? When we have time today, I will show you how you work out that quiz, just some handful of examples, okay? Some examples. And today we have 2 hours lecture, so we should have time. So now, right? So your terminal could be here, right? And we know how to find the many angles with the same terminals, right? Now, what does it mean at the point x comma y? X comma y. right? So the x comma y, the description about x, y is on the terminal side of A, on the terminal side of A, not on the other side, okay? So I'm going to redraw this picture. As a matter of fact, let me just get rid of this one, okay? So on terminal side of X, okay, so first when we read the definition, when you read those definitions in your calculus classes, this is the kind of attention you need to give it to, okay? So suppose I'm gonna get a terminal, okay? And I'm gonna draw this terminal, okay? And this is going to be, so this is my terminal, okay? This is my terminal. And this is terminal, however you measure it. Remember, we spend a lot of time about having the angles, right? It could be counterclockwise, it could be clockwise, it could be going around, any way you measure your angle, okay? You ended up on this terminal. And the point x comma y, xy is the, what is it? Is on the terminal sides, okay? On the terminal sides of the angle. So I'm going to mark a point, okay? Just arbitrarily. As a matter of fact, I should be doing a different point. Let me do this, okay? Forgive me, I'm going to do a point. Wow. Okay, this is a terminal, right? This is my terminal. It looks okay. And then I'm gonna have a point. Okay, that's xy. And xy is arbitrary point. Okay, I want you to understand that. The point is on the terminal side of A other than the origin. What does that mean? It means any point. Okay, any point. So this point I'm gonna have is, it's just gonna be on the terminal sides of the angle. Oh, where's that point? Did I put it? Oh, I know why. My scale is not so I need to make some adjustment, right? To make sure you get to see the point, right? So you still don't see it because I need to adjust the view. I need to adjust the view, okay? So I'm gonna make it happen. So now you should see the point. You should see the point, right? But what's important about these sentences is that this point is arbitrarily chosen. Arbitrarily chosen. So I could have chosen, you know, I could have chosen the point to be here, to be there, to be, you know, way up, right? Anywhere. Other than the origin. Other than the origin. What does that mean? We cannot choose the origin. Now, this point is not eligible for such selection. Now, you may wonder why, right? Wouldn't origin be the very simple point to choose? Well, if you do that, there will be some serious consequences, right? And we will find out. You see, every word, when you read the definition, every word counts. You can't just read it once and then go on and start to do your homework and you're going to ace your course. That's never going to happen. I tell you, I assure you. Okay, I've tried that myself. All right. So with these, the definition comes. The definition comes. Okay. So now, arbitrarily chosen point xy. So now this is the point. This is the point. So I'm going to mark it. I'm going to mark this point. So I want you guys to do this with me, okay? Because I'm showing you the way to study mathematics. even when you're in calculus classes. Okay, this is how you study. So next, I'm going to mark that point. Okay, because it's just make it easier to see it, right? So I'm marking that point. Okay, so that point I'm going to mark. Let's see. I'm going to make it. I'm just going to just for the graph. This is something I want you to put on your graph, right? X comma y. Okay, maybe I should move up just a little bit, right? And the letters need some adjustment. Okay, so I make it 5, and I adjust the fonts. Well, that's something I have to worry about. You don't need to worry about this. Okay. So that's the point. There, X comma y. Nicer looking, right? It's nicer looking. All of this is part of the bridge. And then on top of that, another variable another symbol is introduced. It's called R equals to the square root of x squared plus y squared. What is that? Well, if we have x comma y, we need to understand what is x, what is y. What is x? What is the visual for x? What is the visual for y? The very basic, right? X is the horizontal measurement. Okay, because we're in the rectangular system, right? The horizontal measurement from the origin to the point, that's x. And what is y? What is y? Y is the vertical measurement from the point. So this much. And what has happened? This is a right triangle, the 2 right triangles here, right? 2 sides, 2 parallel sides, the blue and the part of the red, right? So this is x, this is y. And let me mark the x, okay? U2, this is x. Oh, I will try to make it color tuned. Okay, color toned. So this is y. The green is y. The blue is x. Right? And this piece is green as well. This piece is green as well. They're the same height, and this piece is x, right? Does everybody see that? Am I going too slow? So this is x, right? This is x, and that is y. It's a big rectangle, right? 2 triangles, 2 right triangles, 2 right triangles. Y, x, right? Now, what's the meaning of R? What is the meaning of R?
Reference angle.
I'm sorry?
The reference angle for R.
So R is what?
Would R be the reference angle from an angle A?
Can you type that word?
Reference angle, Professor. It is not reference angle. It is the terminal side of the, you can call it reference angle. Professor, yes. Am I right, Jacob? Is that what you're trying to say, reference angle?
Yes.
What I just didn't get that word. I'm sorry. It's not your fault. It's just I don't get the word. What is R? What is R? Could you say it again? I'm sorry. I just didn't get that word you said.
Reference angle.
Reference angle. Okay. Thank you. So the comment says R is a reference angle. Okay, so let's hold on to that answer. Okay, so now when we read up to this point, what is R? Right? So one answer is saying reference angle. So we're gonna see if it is. Okay, now we look at x squared plus y squared, right? This is x, this is y. If I just look at this triangle, right? You can look at the one on the top, you can look at on the bottom. So this piece is x, right? This piece is x. Right? Yes?
Mm-hmm.
What is x squared? Oh, hold on. Sorry. What is x squared plus y squared? What is x squared plus y squared? I'm sorry, it's kind of shifted. Okay. But that's okay. Let me see if it will shift it back. Okay, shift it back. What is x squared plus y squared? What is x squared plus y squared? This is a right triangle. Okay, this is a right triangle, 90 degrees, right? 90 degrees. So we're only looking at this lower one. Okay, we're looking at this one. What is x squared plus y squared? Have you guys learned something called Pythagorean Theorem? You guys learned what is Pythagorean Theorem? Yes. What does Pythagorean theorem say? What does Pythagorean theorem say? The sum of squares of the legs of the right triangle is the same as the square of the hypotenuse, right? Okay, so this is a right triangle. The two legs, the leg x, leg y. X squared plus y squared is equals to what? The hypotenuse. So this side is hypotenuse. This is r. This is r. X squared plus y squared is equals to r squared. R is the length. It's the length. Okay, R is the length of the diagonal. It's not a reference angle. Are you guys with me?
Yes.
R is a diagonal. It's the length of the diagonal. You guys know what's diagonal? Is that the right spelling? Doesn't feel right. Diagonal. Diagonal. Yeah, that's the right spelling. Diagonal. Thank you. So R is not a reference angle. It's the length of the diagonal. So x squared plus y squared is r squared, from which if we take square root on both sides, okay, but this is just keep shifting. Okay, hold on. What I'm going to do, I'm going to put it here, right? So from this, that's shifting. Okay. From this, if we take square root on both sides, what do we get? We get square root of r squared, okay, equals to the square root of x squared plus y squared. Okay, and what does the square root of r squared mean? What does that equal to? What does that equal to? What does that equal to? What does square root of r squared equal to?
Chat respond also.
I see that. Does everybody agree with it? Are you telling me the square root of r squared is equal to r? Does that look familiar to us? It is wrong. What should it be? Absolute value. Remember the number one mistake in Cal? The number one mistake in all of the math classes? Absolute value. Okay, so this piece equals to absolute value of r. All right, just wait. I'll tell you. You know, I will get there. Okay. Now you have the picture in your mind, so I'm just going to clean it for now, right? So how do we get to here? Well, by solving this equation from Pythagorean theorem, we actually get a 2r. We actually get two r's. One is a positive and the other one is a negative. Okay, one is a positive, the other one is a negative. The negative one is not fitting to be a length. So we choose the positive one. We choose r equals to the positive one because this is a description of the length of the diagonal. But when you go through the steps, on that step, you must show this. Otherwise, you might lose point. It depends on who's your professor. You guys follow me? So to be safe, you just do this. Choose this because the length of the diagonal is wanted. Do you guys follow me? So in the future, when you do anything of this sort, when you encounter that, your safest bet is always to do this. And then you have a positive, you have a negative, you choose in between because there will be other conditions that tells you which one to choose. In this situation, we are choosing the length of the diagonal. Okay, so let's go back to see. So now I want to give you the complete picture for this part of work. Okay, so you can take notes. Now, this is x. Okay, so that's not thick enough. Okay, this is x. And that is y. Okay, so this is x. And the other one is y, and that is r. In this process, okay, so this is r. Let me write it down. This is r. Okay, they're color matched. R is always taken, we always taken the positive for the R. Okay, why we cannot choose a point on the origin? Now let's other than the origin. Why other than the origin? Because if you chose XY at the origin, R will be 0. So this condition will ensure what? So this condition, even though it's not explicitly spelled, it implies that R is always positive. You guys follow me? So this is just analyzing the words in definition, and you put on, you know, you put this, you know, the information on the stage. We get this much information. You guys follow me? And my tip to you in the future, whenever you encounter the square root of something squared, you just come out with absolute value. That will ensure you get the points. If you don't listen, I assure you, you're gonna lose some points at some point, plural. Okay, so these are the bits and pieces and places you could lose points easily. All right. So are you done taking notes? So this is the stage set, right? Everything is specified. X, Y, meaning of X, the meaning of Y, and R, right? R is the actual length of the diagonal. R is always positive. The way it's being defined is always positive. How about XY? Are XY always positive? Not necessarily, because if you have the terminal on the other side, on the second quadrant, third quadrant, fourth quadrant, XY may not be positive. Okay, so X may be negative. If on this side, X will be negative. Okay, we're gonna consider all these 4 cases. Okay, we're gonna consider all these 4 cases. That's how you read definition. And that's called critical thinking. That's called critical thinking. Okay, math is not about, oh, I'm just memorized a couple facts, you know, 10 facts. I have a great memory. I can remember 100 formula at the same time. That's not going to get you an A. To get you an A, do what I do. Okay, because everything is in this piece, this paragraph. Everything you need to know is here. Is in this definition. Okay, so I'm going to show you. So now, with this stage set, then what you do? Okay, I'm going to clean this up, right? I'm going to clean this up. Maybe I don't have to now. Okay, so I'm just going to show you the definition of sine, right? What's the definition for sine? Oh, it's just shifting, right? So I'm just going to have to clean it up anyway. So the definition for sine, so after the input is given, and sine, the definition for sine, everybody knows. You used to think that it's the opposite over hypotenuse, right? That's a typical definition in geometry. In geometry, you only consider things in the first quadrant. You don't have to consider the size can be negative. No, the size can be negative. The size can be negative, okay, in trigonometry, okay? So now, what is sine of A? It's y over r. Y over r. Okay, so I'm going to write down these definitions, and you guys write down these definitions, and then we're going to go back to this to see what's going on in the picture. Okay, so that's a definition. So we're introducing some new rules. Cosine is another function, which is x over r. And in the description, we guarantee there's no zero divided by denominator. A zero will not be in the denominator because we said other than the origin, right? Other than the origin, ensure that r will be positive the way we chose r. You guys see that? All these little details you have to attend to, because if you don't, other people will, and they give you questions, they don't know how to answer. Do you follow me? Okay, so r is the length of diagonal, so we're clear about that. And then what? We have a cosine function, so that this is one rule, this is another rule, so we have total 6 rules. And tangent is y over x, and cotangent is x over y, right? And cosecant is 1 over y, and secant is 1 over x. Oh, sorry, r over y. Okay, and this is r over x. So that's a definition. So what are the output? The output are what? Are just different kind of ratios. So inputs are angles for these 6 functions. Output are ratios, and ratios of various sort. Okay, so let me bring back the graph, right? Let's bring back the graph. This is x, right? This is x. And that is y, right? Let's mark it. So let's see, we have the visual. X, oops, color tones, okay? So this is the y, and that's the x. Every symbol properly described to us. Look at that, that's the definition. As a student, okay, I'm a student, you're a student. Right? Even though I'm teaching you, I'm sharing my experience with you, but I was a student before, right? And I still consider myself a student. I'm still learning from this definition. Okay, so I figured that the input are angles, how the angles are measured. I know that. And for each of those angles, there's a reference angle, right? And after each rule give me a ratio. So we have a ratio number 1, ratio number 2, 3, 4, 5, 6. We have 6 ratios. So the output are ratios. The definition of function still has to apply. It must. For each input, there's exactly one output. For each input, there's exactly one output. So we're going to decide the domain and range. You guys follow me? So now, okay. Some of you probably remember from your previous experience that you're going to eventually work on unit circle, right? Then you say, well, in the definition of trig functions, there's no unit circle mentioned. There's no unit circle mentioned. Where does a unit circle comes in? Why unit circle? Right? Why unit circle? You guys know what unit circle, right? Why unit circle? The early mathematicians, just like us, they have a math question, they have a math problem, and they try to simplify it. They try to simplify it so that it becomes manageable. Okay, for example, right now the point I've chosen can be anywhere, right? In fact, on this, on this one, right? it just, if I consider, okay, imagine, okay, imagine this is the radius, right? And I draw a circle. This radius obviously is not 1, right? So the point I have chosen is not on unit circle. And then I'm using the definition, right? And I'll get a bunch of ratios. So if I keep drawing units, if I keep drawing circles, okay, so I'm going to show you a couple of circles we can draw. I'm going to show you some circles, right? If I draw a circle with radius 2, and the xy is on this point, right? Versus I draw another circle with radius 9. Get another circle. If I choose point at all these different places, if I choose a point here, x, y, choose a point here, do I get the same ratio? Okay, let me just draw a few more circles. Let me draw just a few more circles, okay? So because I'm explaining to you why we eventually turn to unit circle. So now suppose I have another circle, okay? And this time is going to be that circle. Right? I can draw all these circles. And I pick my point on these circles. Right? I pick my points on the circles. And of course, those are x, y, right? I'm doing the ratio. I'm going to do the ratio y over r, x over r, y over x, x over y, r over y, r over x. I'm doing all of these ratios. What happens? What will happen? Do you guys understand what I'm doing here? Okay. If those are the points, okay, I'm going to clean up a little bit. Imagine this XY point, this red dot is here, or here, or here. Okay, so let me use dot. Let me use dot because it's just a little bit smaller. So this dot, this dot, this dot. Okay. What happened to these ratios? Because if I choose different points on these different circles, what happens is I will get my different x and different y's, right? So I will have for the smallest one, this is going to be the x, right? This is going to be the x, and this is going to be the y, right? This is going to be the y, right? The blue is x, and this will be the y. Another y, right? Another y. Another y. You guys follow me?
Yes.
Different axes, right? And what's interesting is that if you look at each of these triangles, right? What are the triangles we're looking at? One of the triangles we look at is this triangle versus this triangle. Oh, I'm making a mess, okay? And this triangle. And finally, the largest triangle. Do you guys know what I'm talking about? Okay, so let me clean this up and do it over again. Okay, just look at two of them. Just look at two of them. Suppose, okay, I'm looking at this triangle, right? And I'm looking at this triangle. Okay. The larger triangle, which is this dot, that dot, and the smaller triangle, these two triangles are what? They are similar. aren't they? Did you guys have any, even if you don't remember much about your geometry, do you agree that these two triangles are similar triangles? What do we mean by similar? In this case, their angles are, this angle is a common angle. Okay, so this smaller triangle and the larger triangle share this angle. And this piece, right, this angle and this angle, they're the same angle because they're parallel lines, right? And this diagonal cross these two parallel lines. So these two angles are the same, and the other angles are the same because they're both 90 degrees. So these two triangles are similar triangles. As a result, the ratio, right? The ratio, so this ratio, so I call it Y1, right? And that R, that is this long R, I call it R1. Okay, and this other triangle, I call it Y2. And I will call this other one, this piece, R2. Because these two are similar triangles, so their ratios of Y over R are exactly the same. You guys follow me? The ratios are the same. So it doesn't matter which point you choose on the terminal. You can choose anywhere. They're going to give you the same ratio. So what we are saying here that, okay, let me write it down over here. The ratio of Y1 over R1 is going to be the same as Y2 over R2. And this list can go on if you choose any other points on the terminal the same way. It might be on different circles, right? It might be on different circles. So for this reason, if I choose the unit circle, what does it mean unit circle? Unit circle's radius is 1, okay? So on the unit circle, suppose I have a Y and the radius is R, but the R is 1. All of these ratios and many more you can create would be the same. Do you guys follow me? For that reason, we decide to use unit circle because unit circle will significantly reduce our calculation. You follow me? Because of all these triangles are similar. You get it? Everybody?
Yes.
That's why we use unit circle. Because all of these ratios, doesn't matter where you choose the point, they're always going to be the same. Okay, so after the definition, okay, I'm going to clean this up. Did you guys write it down? Okay, so now, after someone read the definition, okay, and this someone, maybe a mathematician 200 years ago, and he was thinking, how can I make this simpler? And then he figured out these similar triangles, and then he realized, voila, if I work this on a unit circle with radius equals to 1, it will significantly reduce the amount of calculation I have to do. All right? Okay? So now, that's why we choose unit circle, right? That's why you always see unit circles about trigonometry, In fact, you can use, radius 4, radius 10, radius 100. You can use any one of those. It's not going to change the ratio. So if they're not going to change the ratio, why don't we just choose the simple one, choose the easy one? So that explains why unit circle. So you guys got it, right? And next, let's look. What if we use unit circle? So we're going to rewrite the definition, right? We're going to rewrite the definition. And this time, we're going to use unit circle. So I'm going to copy and paste the whole thing and put it on the very top. Let's see what happens if we choose unit circle, right? We still follow the definition. And this time we make x, y on the terminal side of other than the origin, but on unit circle. On unit circle. Okay, then in this case, what is R? What is R? R would be equals to what? So the work is greatly reduced. R equals to 1. R equals to 1. R equals to 1. Okay, if R equals to 1, I'm going to redo this picture. Okay, I'm going to remove all of these other accessories. So I'm going to delete. Wait, I might have deleted too many. Okay, so I'm going to delete some stuff. Okay. Delete, 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 delete. All right. Clean up. Now I want unit circle. Now I want unit circle. So I'm going to make adjustment on the unit circle because it doesn't make any difference, right? So now I'm going to just do the unit circle. So that's how that looks like. Okay. That's my unit circle. It's going to be a little small, right? But I'm going to put the points on the unit circle. So it's still a point on the unit circle. Okay, now I love this point because unit circle make my life so much easier. Okay, unit circle make our life so much easier. So we choose this point on the unit circle. What if that happens? If that happens on the unit circle, what will happen to the definition? The R becomes what? Becomes 1. 1. 1. 1. Do you guys follow me? Do you guys follow me? Okay.
Yes.
All right. So that's the journey up to unit circle. Next, what I'm going to do with you is that we're still going to use a definition which is closely related to your quiz number 10. We're going to do something that's not on unit circle. We're going to do something that's not on unit circle. Okay. And I'm going to create a similar example for you. I'm going to create a similar example for you. Okay. So, and then we'll see how we work it out. Okay, how we work it out. So this is the journey up to unit circle. Let's go back to the original definition. Let's go back to the original definition. Okay, so we're going to work this out one more time. Without using unit circle, okay? But we finished that. This example will be closely related to your quiz number 10, okay? Related to quiz number 10. Because I want you guys to use the definition, whether it's on unit circle or not. Why? Because in your calculus class, you don't necessarily have a point on unit circle. And in your future courses, you don't even always have a point on unit circle. You still have to work, you still need to know how to work it. Okay, so now for that reason, and besides, I told you the definition is so important. So we have to know how to use it. So I bring back the definition. So I bring back the whole thing, okay? Trust me, eventually we get to the unit circle, but afterwards, okay? So what I'm gonna do is that I'm gonna give you a point. I'm gonna give you some points, okay? We're gonna apply the definition. We're gonna see how we apply the definition, okay? So now I'm gonna give you, I'm gonna do some cleanup. Okay, this remind me of the song by Barney, right? Clean up, right? You remember that song? Any one of you? So now I have clean up. I have a cleanup. The points I'm going to give you, this time it will be a real point. Okay, it will be a real point. And this point, I mean, I'm giving you is going to be 5, 12. 5, 12. 5, 12. Okay, just pretending. It's not to the proportion. Right? It's just 5, 12. And this is the point we have chosen. That's x, y. Okay, so I'm going to give you 4 points. And we're going to apply definitions. Are you guys ready? So let's do the first one. Are you ready? If it's a 5, 12, maybe I'll try to make it a proportional. Okay, I don't want to confuse you, right? I can easily make it proportional. That's not a big problem. Let me do that. Okay, so that's the point. Arbitrarily chosen. Okay, so now we're going to use the definition. So that's the intention of quiz number 10. Okay, that's the intention of quiz number 10. So we have this point here. Okay, so let me just make that point look a little prettier. So I'll make it 4, 5. Make it better. Okay, 5, 12. Better looking, right? So I want to show you guys how I would use definition to get the output. Okay, the angle I get will be terminates on this line, right? So this is the angle that terminates. This is a terminal of many angles. It's terminal, there are many of them, but it's a terminal, right? Suppose you call that angle that terminates here as something, you can call it, alpha, right? You can call it alpha. And this is the reference angle, right, as well. They're different from the actual angle, but you can see this is a positive acute angle there, right? How do we find sine in this case? Well, we first have to find r, right? What is r? R is equal to what? What is r equals to? Can you guys get your paper, pencil, and work with me? This is 5, and this is 12, right? Yes? 5 squared plus 12 squared. I'm going to do some of them, and I'm going to give you another example and when we go to the breakout rooms. You follow me? Yes?
I am ready, Professor, with my board and
but I will be doing, some examples, and then we do the breakout rooms, okay? Now, so 5 squared plus 12 squared. What is 5 squared plus 12 squared? That's 25 plus what? Plus 144, right? Yes? And what does that equal to?
A equals the square root of 169.
169, right? And what is
Which
square
is
root of
10.
169? 13, right?
Yeah.
Right. So you see, I choose the numbers deliberately so it's easier to calculate. Could I choose a messy number? Of course I can. I would do the easy ones. I'll give you the messy numbers. How about that? Right? All right. But you can also handle it because I trust you can, right? If you can, you must, right? All right. So now we have X. So now I want you guys to write down. Okay. I want you guys to write down. R is equals to, in this case, right? Our X is what? X is 5. X is 5. Y is what? Y is 12. And as a result, R is what? R is 13, right? R is always positive. And now let's produce these ratios. Let's produce these ratios. Right? Let's produce these ratios. So what is Y over R? Y over R. That's 12 over R, right? What is X? What is the cosine? Cosine of the angle? What does it equal to? X is 5, right? So 5 over 12, or 5 over 13, right? Yes? How about Y over X? Y over X? 12 over 5, right? And cotangent is what? 12, oh, sorry. Y is 5. Sorry, I made a mistake.
Y is 12.
Y is 12, okay. Cotangent X over Y. X is 5. So I was right there, right? You guys better keep an eye on me, okay?
Yes, you were right.
You don't want me to get away with my mistake, do you?
The square root on 169 was deleted by probably computer or something. If you revisit the square root of 169 equals 13 just 5 minutes ago.
Yeah, I deleted it. I did it.
Oh, okay. Thank you.
I'm the criminal. Okay? Because I want to make space. I want to make space. All right? So how about this one? R over Y, what does that equal to? 13 over what? Y is what? Y is 12, right? You guys see that? And this one, secant is 5, no, 13 over 5, right? Are you guys with me?
Yes.
Yes.
Okay. I need to make a special announcement for you. On quiz number 10, you need to provide exact answer. What does that mean? Some exact answers has a decimal form. Some exact answer does not have an exact decimal form. Okay, for example, 13 over 5, there's an exact decimal form. So the program will accept both form. But 12 over 13, okay, there's no exact decimal form because you're gonna have lots of decimal places, and that has to be truncated. You have to round it. If you round it, it's not exact. You guys follow me? So in that case, you have to give the exact form. I sent you guys a message yesterday because someone started doing the quiz, and the answer was, the answer should be the fraction. So for example, the answer is 1/3. Just take an example. If the answer is 1/3 and you give 0.33, it will not accept it. Then you say, oh, 0.33 is 1/3. No, 0.33 is not 1/3. Do you guys hear the word exact? Because we want exact. All of your math professors, they want exact. Okay? That's why eventually they work with the special triangles, because we have exact form. Other non-special triangles will be messier and they don't want to deal with it. Because the point we're assessing you, it's not about getting decimal or thing with a decimal number or fraction. We just want you to get the idea. What is the idea we want you to get? ARD. Okay. So when you go to four-year schools, remember those math professors are just obsessed with exact. Give them the exact to get your point and graduate. How about that? Okay. Are you with me? Because I've been there. I've been there. They want exact. And what is more, they want fraction. They like fraction. Just like me, even more obsessive. Okay. What can you do about it? Can you change all of them? Can you change those professors? Say, oh, can you guys drop your? No, you can't. You can't. There are too many of them. You can't change them. Just get over it. Just get over it. You guys with me? There's nothing personal about it. Just about getting the points. So use fraction if you can. Use the precise numerical value. For example, here. Okay, I'm just giving you an example. Because this one has a precise numerical value. What am I doing here? This is not what I wanted. Sorry. Okay. I'm just taking an example. Okay. For example, 13/5. 13/5. If you encounter this question, your answer should be 13/5 or, oh, give me the numerical value. 2.6. In this case, 2.6 is precise. 13/5 is precise. Just give either one, the program will take it and give you the credit. In another case, so if you have 12/13, unfortunately, there's too many digits. There are even more digits afterwards. If you chop it off, if you say, oh, I'm going to choose 0.9, no, 0.9 will not be considered exact. So in this case, you don't have another exact answer. And of course, your fraction need to be simplified. Your fraction need to be simplified. Got it?
Wait, I have one quick question.
Okay, yeah.
So an example would be like, say you do 5/12, you would have to leave it exactly like 5/12 because then the decimal point is like 0.41. You wouldn't use that. You only use 5/12, right?
Whenever you have to round it, that's not exact.
Okay.
Okay, whenever you round it, however sophisticated your calculator is, if you have to round it, that rounded number is no longer exact. So just drop it.
Okay.
And your professor don't like them.
Okay.
Just give the fraction. Just give the fraction. How about that? Is that clear?
Yeah, I was gonna say, like, can we just leave it as a fraction and not put as 2.6?
Yeah, you can. In this case, I would use 13/5.
Okay.
Okay. I know there's this gap and there's this this kind of misunderstanding of some sort. I don't know. I want to be clear with you. Okay. I know a lot of you don't like fraction. You always want to punch in the calculator and you want to get the number, get the decimal. Okay. But your professors at four-year schools or anywhere, they're very good at fractions. They expect you to be good at fractions too, right? And you want to get points from them, do you? What do? Give them fractions, right? Does that make sense?
Yes.
All right, so that's as simple as clear as that. If you do that, you get points. If you don't, you may lose some point. I say you may. Depends on who's teaching. But in general, I would say 99.9999% of them, they want that exact value, period. If you haven't figured that out, now, I told you, okay? And you get your point, you graduate, you get your job, and you can forget about it, right? Is that clear? All right, so this is a whole example. This is the whole journey of using definition. Okay, would you allow me to, do you need another example?
Yeah, why not?
Okay, if you want another example, I'm going to give you another point. Okay, I'm going to give you another point. And this point, we're going to do it together. I'm just going to give it a try. Okay, this point. Okay, -5, -12. I'm going to make the fonts a little bit smaller. Okay, so this is a different terminal. This is a different terminal. Okay, so I'm going to draw the terminal for you. Okay, and the point, I'm also going to mark the points for you. It's going to be a red dot. -5, -12, a red dot. -5, -12. Okay, this point is marked in the wrong place. Okay, don't worry about it. Now I want you guys to work with this. Okay, so X is going to be -5, Y is going to be -12, and you're going to do the definition. Are you guys clear? Do you want to have a head start now? So you're going to do the R for this point. I'm going to make some adjustment to correct that point, okay? So I'm going to just 512. I'm just going to just change my point because my 512 has to move. That's better. Okay, so I don't want to confuse you. That's why. Okay, so for this other point, you're going to go through the whole journey. Now this line is a terminal. Okay, so forget about this piece. You follow me? Forget about this piece. Now you're dealing with this terminal. This terminal is the terminal you're dealing with. And the point on the line is -5, -12. So you're gonna find the R and you're gonna find the ratios. You guys know what to do? Yeah? I'm gonna get started for you. Okay, I'm gonna get started. So for points, okay. So I'm gonna bring this picture with me. I'm also gonna bring the definition with me. Okay, but this time, everything has to be redone. Everything has to be redone. Okay, and in this case, x equals to -5, y equals to -12, and r equals to what? What does r equal to? R equals to x squared plus y squared. So there's going to be -5 squared plus -12 squared. Okay, and that equals to -5 squared is 25, 15, plus 144. And that will end up to be square root of 169. The square root of 169 is 13. Yes? So R is 13. Do you follow me?
Yes.
And then what you do, you go to the definition, then you're going to do what? Y over R, right? Y over R. Y is what? Y is -12. R is 13. So you go through that list one more time. Do you follow me? -5, 12. And so on and so forth. Are you guys with me? Can you do that? Because I'm going to give you 2 more points. After we come back, I think I should give you a break. You ready? So y is -12, x is -5. You simplify. What is this mess? -5. Okay, so now it's just you don't get to see the negative sign, right? I'm sorry. The negative sign. In this case, simplify. -12 over -5 is 12 over 5. And these, you can just write it as -5 over 12. Right? And this will be -12 over 13. You guys see that? 12 over 13. Got it? So you can see, so this is going to be -5 over -12. And that's 5 over 12. Last two. So that's going to be 13 over -12. That's a -13 over 12. Okay, equals to 13 over -5. So -13 over 5. Do you guys get it? Apply definition. That's all I want you to do. So quiz number, you did cosine A wrong. Oh, yes, you're right. This is 13. Thank you. Thank you for spotting my mistake. Great job. You guys get it? All right, so I'm gonna give you a break for 5 minutes. I'm gonna give you 2 other points. Okay, when you come back, we're gonna have a breakout rooms if you wish. And so while you're taking the break, I'm not gonna take a break. Okay, so go have a break. I'm gonna put the other 2 points on the graph. Are you ready? All right. So I'm gonna put these on the top. Okay. So all of these, right? We have the stage set. We have the stage set. By this time, you should be super familiar with the stage set. Okay, I'm fixing those questions for you. But go ahead, take your break, really. Okay, please do. And the last point. All right, 2 more minutes. 2 more minutes. Okay, I'll be right back. All right, guys, come back. Come back. Now, do you know what to do? Do you guys know what to do?
Yes.
All right. So now you can see while you're taking the break, I made it 2 more points for you. Okay. 2 more points. Two more points. And you are going to apply the definition. You're going to apply the definition and put the 2 more points. So for each point, which is on a terminal, and another point is on the terminal, you are going to compose the definition. Is that clear? Now, let me specify this, okay? For a point, for point -5, 12, on a terminal in quadrant 2, apply definition. Is that clear, everybody? Yes? To get those ratios. to get those ratios. Okay, so all of these has to be, you have to fill in your work for this specific point. Okay, I want you guys to write this down before you choose to do your work. You know, I just want to clearly specify the point, specify the task. Okay, so one point is 5, 12. And so you're gonna identify X, Y, R. Okay, and then the next one will be for the other point. 5, negative 12. Okay, so you're gonna apply definition, do all of that. And the picture is right here. And you have a picture here. And you have another picture over here. Okay, so let me make the font just a little bit smaller. So I don't think you can see all of it, but you got it? Did you get it? What to do? Did you guys get it? Yes or no? No answer, no answer.
So Professor, by the definition, you mean sine A equals Y over R, so on and so forth. Is that what you mean?
Yes, that's the definition.
That's it.
That's it, okay? So I'm gonna open the breakout rooms. And you self-select, open all the rooms. So now let's go. Ready? Let's go. Let's do it. All right, let's do it. All right. So if you stay with me, we're gonna work on this point, right? So we're gonna identify X equals something, Y equals something, and R equals to something. Right? Y equals to something, R equals to something. So R is X squared plus Y squared and taken square root. Okay, if any one of you want to go to Farouz, go to that room. So X is -5, Y is 12. So when we plug in, over here, so you're gonna have -5 squared plus 12 squared. Okay, and then you're gonna work your magic. Right? So 25 plus 144 equals to the root of 169. And that R is going to be 13. And then you just plug them in, right? Y is what? Y is 12. R is 13. Cosine is X -5 over what? Over 13. Tangent. You guys know what to do now? I think you already know it. It just have the patience to do it. Okay. So I'm gonna save some work for you. I'm not gonna do it all. So go for it. Go for it.
Professor, I came back here. Nobody chosen me yet, but
nobody went there. Okay.
I'm writing on my boards in case if anybody gets interested. So they will let me know. Or...
No problem. No problem, Farouz. I think they all got it.
Yes.
They all got it, which is great, right? It's good for you and good for me.
That's right. That's right. So I wrote on my board, I want to share it with you also. This is for x negative 5y 12 r3, and here I was writing for the other point you were giving me. So preparing the stage, as you said, in case if anybody wants more practice. And also, Professor, I have based on the exact answer, I got by experience, I found one of the, by experience, I found one of the inexpensive calculator, scientific calculator can give the exact answer, save the time for a student. So I have the model number, everything written in the board here. If anybody interested, they can Google it, shopping around, and tax included, you can get it less than $20.
Okay, that's good.
Anything above, no, you can shop around and get it. So last time I checked with the student, got it, Office Depot, $15.48 plus tax. That's it. And but yeah, so that is something I could share with the student because it's.
Yeah, that's great. Thank you for sharing that with us. And did you guys see that if you want to get a calculator, even though I don't require a calculator, but I know you guys all have it, right? I don't use a calculator. And, you know, I encourage you guys to try to use less calculator and try to think some more, try to make connection more, and try to work with definition more. And those are the key to successes. Those are the key to successes, okay? Because if a calculator just takes so much of your time and it just work with fraction, okay? You just cannot get away with it without doing fraction. And then you also get frustrated. How come I don't get the point? Because he didn't give the exact answer. Even though that one point, it's maybe just 1 point being dodged from you. You don't want that to happen, right? But anyway, thank you, Farouz.
You're welcome. You're welcome.
All right. Did you guys finish this third one? -5, 12, right? You know what to do, yes? Just plug in the numbers, right? But you understand, you know, this exercise we're doing together is for a very important reason, is that I want you guys to really understand the definition. Okay, I want you guys to really understand the definition. And then we're going to start observing. Okay? So the more good things is coming our way. Tangent A is y over x. Okay, so what answer do I get? I would like to take some input from you. Y over x, what do we get here?
We get 12 -5, which then becomes -12 over 5.
Is it 12 over 5 or?
No, the first part is 12 over -5.
Over -5.
And then you have to like put it on top, so it just becomes -12 over 5.
Wonderful, wonderful, great job. How about cotangent A? You know, when we are doing this, we actually review the number skills is actually from pre-algebra. Okay, so that's why we do these in the details. Remember, this is 5 courses in one. Sometimes we just have to do across all 5 courses. Okay, you guys with me? So review your number skills. Okay, you guys doing great. Next, cotangent. What's cotangent? You must have paper with you. Okay, paper, pencil with you. Pen is okay too. And erasers, right? Pen, paper, pencil with you. X over Y. What is X over Y?
I got -5 over 12.
Wonderful. And then you just write it in the standard form, -5 over 12, right? And last but not least, last two. What is
I
it?
got 13 over 12.
13 over 12. Wonderful. Last.
And then it's 13 over -5, but you have to flip it. So it's -13 over 5.
Great job. You see, you are doing it. You are doing it. Great job. Great job. Okay. So can we get to the last one? Or could I leave it for you? The last one. Let's do it quickly. Okay, let's do it quickly, shall we? So what is the x value? X is 5. Y is what? -12. And what is R? R is 5 squared. Oh, 5 to the power of 5, sorry. 5 squared plus -12 squared, right? And then what you do? This is 25. This is 144 equals to 13, right? So now you put the numbers in place. So I hope you guys are not terribly bored. Are you bored? Does this become easier and easier? Yes? And the numbers I give you on the quiz is simpler than these. Okay, so x is 5, r is 13, y over x, y over x. What is y over x? -12 over 5. So this is going to be -12 over 5. And x over y. So x is 5. No, I'm sorry. Yeah, x is 5. Y is -12. So that's going to be negative. Do we discover something in the process? Do we discover something in the process? All right. So 13 over 5. Am I right? You see how straightforward it is? Just apply definition in the different scenarios. So what I want you to experience, and you see that those angles, input are angles and the output are what? The output are ratios. The output are ratios. Okay. Now, we're going to do any questions so far? Are we too slow? No? Are we too slow? No? Okay. So now let's observe. Let's observe, right? We do these examples. And what do we want to observe? Okay, so let's look at the first one, right? In the first quadrant, let's go back here. In the first quadrant, every function gave us a positive ratios. Yes? Every function gave us positive ratio. There's just different kinds of ratios. One is the reciprocal of the other, aren't they? For example, tangent and cotangent are reciprocals to each other, aren't they? Right? And cosecant and sine are reciprocals to each other, aren't they? And secant and cosine are reciprocal to each other. So these 6 functions are really just ratios of different kinds, aren't they? Do you follow me? As a matter of fact, because when the angle have a terminal in the first quadrant, y is positive. So sine is always positive in the first quadrant. Are you guys with me? Cosine is positive in the first quadrant. Okay, because x is always positive in the first quadrant. Right? Do you guys follow me? Y are positive, x is positive. So positive divided by positive is what? Positive. X is positive, y is positive. Positive divided by positive is positive. The same thing for cosecant and secant, right? For secant, r is always positive. So when y is positive, cosecant is positive. R is always positive. Therefore, when x is positive, the ratio is positive. Are you guys following me?
Yes.
Okay. Now let's look at the second quadrant, right? We did the second quadrant later. This is the second quadrant issue. Okay, negative 5, 12, negative 5, 12. Negative 5, 12 is in the second quadrant, right? No, this is the wrong one. No, that was the fourth quadrant. This is the second quadrant, my bad. Negative 5, 12 is in the second quadrant, right? This is negative 5, 12, right? This is the part we did, right? Yes? Negative 5, 12. In the second quadrant, sine, y is used, right? Y is used. Y over r. If y is positive on the second quadrant, and sine is defined by y over r, therefore the ratio is positive. So sine is positive in the first two quadrants. Do you guys follow me? So do you have to make a special effort to memorize it? I know some of you have. You have to bang your head on the wall. Sine is positive, negative, cosine is tangent. Well, by observing these numbers, by observing definitions, we're going to get there's a wealth of information out there. Okay. So now with what we have done, I want you guys to put your note on this, put your note and start another page. So we're going to take a second look about these definitions. Okay, about the sign of the output. Okay, we're still on the definition, right? We're on the stage. So about the signs of the trig function, of these functions. Okay, so in order to determine the sign of the function, I'm going to remove these special cases. And I want you to refer to the examples we just did. Okay, and what is more, we're going to start with the quadrant. We start with the quadrant. Okay, and the quadrant goes like this. Y equals to 0. I'm just going to start with the quadrant. Could you guys do that with me? I want you to see how natural a lot of the results that arrange in different chapters of the book, how they all stemmed from the same place. Okay, which is definition. Okay, so here we have the definition, right? If you look at these four quadrants, right? In this quadrant, in the first quadrant, right? In the first quadrant, x is positive, right? Y is positive, right? Yes?
Yeah.
In the second quadrant, x is negative. Y is what? Positive, right? In this quadrant, x is negative, y is negative, right? In the last quadrant, x is positive, y is negative. Now you look at the definition. You look at the definition. The definition, in the definition, we know R is always a positive, right? R is always a positive. So for sine, it's y over R. So sine, the sine for sine of angle is always the same as the sine of y, yeah? If y is positive, in the first quadrant, okay, y is positive in this quadrant, quadrant 1 and quadrant 2, and y is negative in quadrant 3 and quadrant 4, what does that tell you? It tells you sine is positive, positive, negative, negative. Is that right? Yes. Does that make sense? So from the definition, it tells us the sign. Which property is being applied here? Remember the 6 mathematical principle. Which principle is applied here? Principle number 6, right? Positive divided by positive is positive. Negative divided by positive is negative. Is that right? Do you guys follow me? Principle, mathematical principles. So now let's look at cosine. For cosine, I'm going to use blue. Cosine is x over r. R is always positive. So what happened to x? X is positive in the first quadrant, negative in the second quadrant, negative in the third quadrant, positive in the fourth quadrant. So what does that tell you about cosine? Cosine is positive, negative, negative, positive. Are you guys with me? And look at principle number 6. Do you follow me? Does everybody follow me? Yeah?
Yes.
Okay. So with all these said and done, okay, let's do a little summary. Okay. So what I'm going to do is I'm going to copy this picture and I just put it on the side. He created a mess for me. But that's okay. We can do it again, right? So now, okay, now we have some ideas about positive, about the signs, right? So let's summarize. So sine is positive. So if this is sine, okay, sine is a positive, positive, negative, negative, right? So let me make a table for you. I'm going to make a table for you, okay? So from the quadrant, I want to encourage you guys to draw the to do the summary, okay? To do the summary to see how natural it comes with definition, okay? So sines, I'm gonna make some columns, okay? So on these columns, I'm gonna put all of these things here. And I want you guys to observe with me, right? (125%). Okay, so all 4 of them are here. Okay, knowing the definition, and also knowing we don't need this. So this is for sine, A, cosine A, tan A, cotangent A. Okay, so let's focus on sine and cosine. Let's focus on sine and cosine. For sine and cosine, so now, you know what? I'm going to remove tangent and cotangent for now. Okay, because I want to bring that thing next to us. Okay, so be patient with me. Are you guys tired already? Okay, so I'm going to bring this picture here.
These are
Okay.
poster like a review for a quiz or study guide for the quiz also considered.
Sort of, but it's a study guide for how to. We already did the study guide for quiz number 10, right?
Right. That
We just
practice.
did it. So what I want to do is I want to see everything. I wish I'm in the classroom. I can lay out everything on the board, right? So that's what I'm trying to do. So now we just reviewed, right? In the first quadrant, okay, is a positive. X is positive, Y is positive, right? In the second quadrant, X is negative, Y is positive, right? In the third quadrant, is negative, right? In the fourth quadrant, is positive, negative, right? So now let's look at sine. The definition of sine, what's the definition of sine? Definition of sine is y over r, yeah? Okay. Cosine is x over r. Do you guys see that? Yes? Now, so the sine of, okay, so the sine of sine is determined by y because r is always a positive. So whenever y is positive, x is positive. Sine is positive, sorry. Do you guys follow me? So sine is what? Positive, negative. You follow me? Now, how about cosine? Cosine is x over r. R is always positive. So whenever x is positive, right? Whenever x is positive, cosine is positive. Whenever x is negative, cosine is what? Is negative. Do you guys see that? The red? Do you guys see the red? So
Yeah.
cosine is a positive, negative, positive. Do you guys follow me? So you just don't have to memorize these things. You just have, it's because it's in the definition. That's what I meant. You follow me?
Yes.
How about tangent? Tangent is sine divided by cosine, right? Right? It's sine divided by cosine. So
Yeah.
tangent will be, in the first quadrant will be positive divided by positive. In the second quadrant is a positive divided by negative. In the third quadrant is what happened? Is negative divided by negative. In the fourth quadrant, negative divided by positive. So what principle are we using? Principle number 6. You follow me?
Yes.
So for tangent, can you draw that sign? Can you draw the sign for each quadrant? Okay. So for tangent, what happens? Right? So if I am to have a tangent column, right? So this is 10. In the first quadrant is a positive divide by positive because tangent is what? You can look at this from two perspectives, right? Tangent is y over x, right? Y over x. So y over x, y over x, y over x, y over x. You guys get it? So positive divided by positive is what? For tangent, positive. On the second quadrant, positive divided by negative is negative. On the third quadrant, negative divided by negative, positive. Fourth quadrant, negative divided by positive, negative. You follow me? Does everybody follow me? Once you know how to figure this out, do you need to memorize? It's all originated from the definition, aren't they? Do you guys see what I'm saying? Yes? Right now, we're using nothing else. We're just using definition. We've been with definition. We fell in love with definition. We want to know the inside out of the definition. Okay? So how about cotangent? Cotangent is x divided by y. So cotangent will have the same sign with tangent in every quadrant, right? Look at the definition of cotangent. It's x over y, right? Yes?
Yes.
How about cosecant? Cosecant is r over y. It's a reciprocal of sine. So cosecant have the same sign as what? Cosecant have the same sign as sine, right? It's just r over y. Do you follow me? And secant of A is what? It's a reciprocal of cosine. So this is r over x. So they have the same sign. And tangent and cotangent. X over y. Then you have the sign of these 6 functions all under your radar. You don't have to memorize. It's all started from here. It's all in the definition. Do you guys see that? That's what I meant. You can see if we dig into the definition, we get so much information. Is everybody with me? But the power of definition is not done yet. It's not over yet. There are more. We have to explore more. We will continue to explore more. That's why we say ARD are the pillars of trigonometry, in particular the definition. Okay, AR are necessary to set the stage, but the definition is golden. All right? Did you get it? Did you get it? Good. So my point is that you realize how precious that definition is. You can derive so much things from it. If you keep this way of study, you do this in calculus, you study that the definition of limit, continuity, differentiability, and other concepts that follows, you will have no choice by ASET class. And of course, we need some algebraic skill for sure. We do. Okay, so now this is about the sign of these ratios. Sign of these ratios. Okay, I think I didn't confuse anybody, right? Because this is a little bit off. Have you guys taken the notes? So this is a positive, negative, positive, negative. Is that pretty clear, everybody?
Professor,
Yes.
is that the right time to mention all students like calculus or take calculus?
Yeah.
All students take calculus. Those are the abbreviation for the first quadrant, second, third, fourth quadrant, sign-wise. Sine,
Right.
cosine, tangent.
Right. Yeah. There's so much information, right? I will also give you this story, right? Both my husband and I, but we both teach math. And he teaches at 4-year school. And he said, a lot of students, they will come to them and ask them, how do I prepare for the test? What are you going to test us? Right? You guess what the professor will tell you? Oh, we're just going to test you the basic stuff. We're going to just test you the basic concept. And when they look at the test, and sometimes they don't know what to do. Sometimes they lose lots of points, right? And they're very upset. They go to the professor and say, you say you're going to test the very basic stuff. And the professor, sure, I did. Look, this is how you do it, right? You all use the basic stuff. And it's so true. Because from the basic, so much can be derived. You understand what I mean? I was a student before. I know how that works, right? You see the test, they look nothing but basic, but yet they are from the basic, right? So professor always tell you, I'm just going to test you the basic stuff, right? So I'm just showing you how to study for those basic stuff. You just keep digging, dig. Okay, so now without further ado, I trust you have, get all of these. And so sign-wise, we're done. So from the definition, so let's look at the definition one more time. Let's look at the definition one more time, okay? Recap. So now you know A, we know R, and we know D. Right? We know this is a whole stage set. We know it's a whole stage set. All what we do here, we want to make sure you understand the input for sine, cosine, tangent, cotangent, cosecant, secant. The input are angles. How are these angles measured? They're measured the way we learn in A. Everyone is measured in that way. I want to nail this thing in your head. Okay, and then there's reference angle. Reference angle is the positive acute angle between the terminal and the x-axis. And then comes the definition. From the definition, we know that we actually could have, they're not exactly the opposite over hypotenuse. Because this is a rectangular system. The opposite or the adjacent, these numbers can be positive, can be negative. So you have to consider all 4 cases. It encompasses all 4 cases, right? Next, we want to think about domain and range. Domain. So I'm going to get ourselves started, right? Domain. From the definition, we can already figure out the domain. Okay, you see in the trigonometry textbook, right? The definition was introduced in first chapter. Domain and range actually was covered in chapter 4. How do you make the connections here? That's what you, as a student, you have to learn. Okay, the domain is actually figured out from what? From definition. Okay, you need no one to tell you. All right, so let's look at the definition of sine. Right, let's look at the definition of sine. In the definition, okay, so I'm going to bring back some of my favorite pictures, right? Some of my favorite pictures right here. Okay, I'm going to remove that unit circle as a matter of fact. Okay. If I put this in here, if I put this y here, right? And the square root of x squared plus y squared, right? Okay, let me make the fonts a little bit larger. Let me make the fonts a little bit larger. This quantity, you can see the numerator will never be larger than the denominator. Is that right? Because, observe this. This is the y, right? And this is the x. And what is the r? This is the r, right? Right? The r is always longer or the same in extreme case than the legs. Do you agree with me? Do you agree with me? In other words, the y, okay, as one leg, you just look at the y over r. Y in most of cases is less than r. At most, it is equal to r. In that case, of course, it's no longer a triangle. It is going to be a straight line, right? But as a result, this fraction, this is going to be a fraction, right? This is going to be a fraction. This fraction is always less than or equals to 1, larger than or equals to -1. Do you agree with me? If you look at the examples we did, oops, I'm sorry. Sorry about that. I messed it up. Okay, you guys know what I meant, right? Can I say that this ratio is always between -1 and +1? Do you agree? Yeah. Why? Because if you would just let the terminal turn around, okay, on the same circle, imagine our time is up. But next week, Monday, we're going to focus on the domain and range of these functions. Okay, so I'm going to show you how the definition already told us. So the definition that was introduced in chapter 1 has already told us about the domain and range of all of these functions. Do you guys follow me? Yes, because there's not they don't have enough space to put all of this in one chapter. Therefore, that's why they put it in a different chapter. But as a student, when you study chapter 1, you study chapter 2, you study chapter 3, you study chapter 4, and then you need to bring them together across the chapters to study. because the pages are limited. Okay, there's only so much material they can put in one chapter. Okay. All right, so that will be, will be something we study on Monday. We're going to study the domain and range for these functions. So what we want to see is how we can, figure out the domain and range for all of these functions. In particular, there's three critical functions you need to know is sine, cosine, tangent. Why is only sine, cosine, tangent? Because the other functions, they're either reciprocal, they're all reciprocals of the first three. So if we can master the first three functions, and then the other function will be just piece of cake, because they're just reciprocals. And of course, they have their special, special features, and we're going to get to those on Monday. Okay. Very good job and great participation. And thank you, Farouz, for helping. And I will see you guys on Monday.
Thank you, Professor, very much.
All
Have
right.
a nice weekend. Yes.
You too. Thank you.
Thank you.
Professor?
Yes.
I was gonna ask you if you can do some of the questions from the homework, if that's okay.
Of course. Of course.